In recent years, biologists have started to recognize certain animals as keystone species, a species that creates or maintains a habitat for many other plants and animals. In Ontario, the beaver is just such a species. Unlike most other animals, the beaver actually changes its environment in an active way. In a very short period of time, it can alter a fast-running forest stream into a beaver pond and wetland meadow, providing a home and breeding place for a whole new range of wildlife species. Without the beaver's actions, this process would normally take decades or even centuries. By the early 1900s, beavers were almost extirpated from North America, Europe, and Asia due to trapping and the subsequent draining of lands for agriculture. Estimates of the current North American population are as low as 5% of those present prior to European settlement. We now know that the beaver damming provides essential natural services to people too. Beavers prefer to dam streams in shallow valleys where the flooded area becomes productive wetlands. These cradles of life support biodiversity that rivals tropical rainforests. Almost half of endangered and threatened species in North America rely upon wetlands. Freshwater wetlands have been rated as the world's most valuable land-based ecosystem. Reliably and economically, beavers maintain wetlands that sponge up floodwaters, alleviate droughts and floods because their dams keep water on the land longer, lessen erosion, raise the water table, and act as the Earth's kidneys to purify water. The latter occurs because several feet of silt collect upstream of older beaver dams, and toxins, such as pesticides, are broken down by microbes in the wetlands that the beavers create. Thus, water downstream of dams is cleaner and requires less treatment for human use. The beaver's ability to change the landscape is second only to humans. A single beaver can cut down more than 200 trees every year. In creating a better environment for itself, the beaver dramatically changes the surrounding ecosystem and changes the lives of many other wild species. Dams built across streams or lake outlets affect the shoreline vegetation by raising the water table of the pond and the shoreline soil. New aquatic plants may move into the area. Trees may be downed and stand decaying. Woodpeckers nest in them or feed on insects in the dead trees, while osprey and herons build stick nests on the trees' towers. These water level changes are not simple to local events. By disrupting the flow of water, the beaver may indirectly affect the habitants upstream and downstream from its home territory. A small stream in a forest glade may dry up, changing the types of plants and perhaps animals that can live there. A seasonal pond, used annually by amphibians and other creatures to lay their eggs, may dry up or be flooded. The changes are many, and because of the complexity of the ecosystem, they are difficult to forecast. If kept in repair, dams may stay in place for decades. When beavers abandon their creation, a whole new dynamic is created. Often, there has been a significant buildup of silt and decaying matter in the beaver pond. As a pond drains due to natural seepage or a break in the dam, a sedge or beaver meadow is created. This provides a whole new habitat for wildlife such as Blanding's turtles, swamp sparrows, and meadow jumping mice. Beaver meadows usually have rich fertile soils and have been farmed by many Ontario settlers and farmers because of this. Many environmental decision makers do not fully understand the positive effects the beaver and the dams bring to ecosystems. This is understandable because beavers had been virtually eradicated prior to the development of modern scientific methods. Beavers affected our ecosystems and land in a very extensive and positive way. Modern society has recently begun to realize the benefits of wetlands. This realization marks a turning point in over 300 years of extensive wetland eradication. Beaver dams are the primary natural method for establishing wetlands. Beaver dams represent the only natural method of forming lakes, ponds, and wetlands in most watersheds. The exception to this would be glacial lakes, or lakes formed by geologic activity. One specific example of the missed opportunity of the beaver dams is the stream bank erosion and stream meandering. Numerous textbooks state that stream meandering is caused by physical processes seeking equilibrium, energy dissipation rates. It is also taught that equilibrium will be achieved when the rate of stream bed erosion equals the rate of deposition. Given that beaver dams dissipate flow energy and change channels into stilling ponds, why aren't there more chapters on beaver dams in most geomorphology textbooks? Stream channels would be more stable as still interconnected ponds with energy dissipating steps. Currently, these eroding banks are far more achieving a state of equilibrium and will continue to scour both deeper and wider. One alternative method to stop stream bank erosion and meandering would be to restore beaver dams' erosive meandering areas. Any increase in width or depth of a stream channel cross-section area will reduce the stream velocity in proportion to the increase in the width times depth. Upstream of the dam, sediments are being trapped because of the reduced velocity. The upstream area will silt in, and if the beavers are left undisturbed, the dam will continue to be raised until it actually tops the channel bank and will be built wider beyond the scoured existing banks. The sediment stilling effect becomes more pronounced as the pond gets wider. Ultimately, all of the erosion potential would be stopped. The meadow and the wetland would be restored. Rather than having several hundred yards of eroding stream bank loading the stream with sediments, there will be single dams slowing the water, stilling the sediments, and dissipating the erosive energy. The natural geomorphologic outcome for continents without beaver dams would include more ravines and steep valleys due to the cutting erosive forces of flowing water. As inland river channels deepen, streams that flow into the main river will form. These streams concentrate the precipitation flow, which increases the scouring or deepening of the river channel. This deepening effect amplifies itself. This is the reason that rivers form. The deeper channels increase erosion rates, leading to distinctive ravine topography. Beavers instinctively build dams in areas with more rapidly moving water, which reduces scouring, reducing channel deepening. Beaver dams typically bring the water surface to the top of the riverbank. The sediment deposition in beaver ponds also counteracts scouring. Prior to the 1700s, many streams and rivers may have been actually a series of ponds with steps or dams between them. Early geologists observed this step topography. A very large number of beaver dams will shift precipitation flow from rivers and streams into more and underground flow towards the ocean. Overland flow and underground flow are slower than stream flow for equivalent rates, which reduces peak flow rates in rivers after a precipitation event. Reduction of peak flow reduces flooding and erosion. Underground flow certainly results in no surface erosion. Environmental decision makers must realize that the flat beaver meadow areas left after pools silt in are natural phenomena. The stream will flow through the beaver meadow, but the dam forms a natural energy dissipating drop structure. This grassy meadow will flood during high flows and will continue to capture sediments. The elevated water table caused by the meadow will still contribute to charging the lower stream during periods of drought. The full subsurface reserve would still exist, and the silted-in pond volume will now be part of the subsurface reserve. A 6-year study of beaver tree felling in a riparian forest alongside a beaver pond showed that beaver tree felling removed over 40% of the above-ground biomass of the forest. Before beaver occupation, the forest was dominated by quaking aspen, a favorite browse tree of the beaver. However, after 6 years of beaver foraging, the density and biomass of quaking aspen was dramatically diminished, while the relative density and biomass of tree species that the beaver did not like to eat, and therefore did not cut down, increased. Because beaver avoided cutting prickly ash, dense stands of this shrub persisted within the first 10 to 15 meters of the river, where most trees had been removed. A comparison of beaver foraging in two types of habitat. A high quality with a great proportion of deciduous trees, and B, low quality with a lesser proportion of deciduous trees. Researchers found that, with increasing distance from the pond, beavers in high-quality habitats selected fewer but larger trees, and where more species were selected. This selectivity was diminished in habitats of lower quality. These results are similar to those predicted by a model known as the central place foraging theory. Beaver can reverse or hasten the succession of plant communities. When beaver selectively cut down certain tree species and create sunlight gaps in the forest, species of sun-loving, shade-tolerant plants often regenerate there, converting a mid-successional stand to an early successional stand. However, if the forest is dominated with early successional trees like aspens and willows that the beaver likes, but has an understory of seedling late successional trees that the beaver does not like, such as fir and spruce, tree felling by beaver hastens succession by removing the trees that hinder the growth of the understory tree seedlings. Although beavers are not large animals, they often have a greater impact on riparian forests than larger herbivores such as moose. There are three reasons for this. Firstly, Beaver are the only animals beside humans that can cut down mature trees. Secondly, beaver concentrate their tree felling and foraging in the relatively narrow band of forest surrounding their ponds. And thirdly, beavers remove far more vegetation than they consume because they use wood to build dams and lodges as well as for food. Each year, in northern regions, an average beaver family is reported to cut at least 1 metric ton of wood within approximately 100 meters of their pond.